Okay, this video is showing, I'm going to show you how to find limits by working on what's called a conjugate. Now, this type of limit we don't see it again a whole lot, but when we do see it, we want to do it well. So, if you watched my previous videos on limit techniques, the first one was factoring, and that's by far the most common type of limit problem you'll see where you have to factor. Uh, the other one I just did was combining fractions and then doing some more canceling, writing a reciprocal and so on and canceling. All right, this is another type where we find a conjugate, and this is probably about the last technique, common technique, even though this is not a lot common, uh, of solving limits. And sometimes we have to actually use calculators to estimate limits, or even use what's called L'Hopital's rule for those that we just can't uh, see a algebraic way of doing so. But let's focus on doing these. I just have two examples. Okay, they're not terribly hard. Okay, let's do what we normally do. We're going to try to substitute 0. You see right off the bat we get a 0 in the denominator, and when we substitute 0 into that x in the numerator, we get a square root of 4 plus 0, and then we have a minus 2. 4 plus 0, of course, is 4, and the square root of 4 is 2. So we have a 0 over 0 situation. So it's calling for some kind of algebraic manipulation, so we can actually substitute 0 later. Alright, so the way to do this is actually multiply by the conjugate. The conjugate is really reserved for complex numbers, and so maybe I'm not calling it right, but I'm going to call it the conjugate because really exactly what you should do here. So I look at the square root, I see a square root of 4 plus x. After that I see a minus and a 2. I'm going to multiply by this. I'm going to use the same thing, a 4 plus x inside there and a 2 in the back, but I'm going to put a plus 2. Okay, these two are going to cancel out. Okay, going to help us do some when we combine terms, some canceling, just like when you multiply complex numbers, you multiply by the conjugate, so you can cancel out the two middle terms. Okay, so but let's multiply. We have to multiply the denominator by the same thing. Okay, and it's not anything to panic about. It looks like a whole bunch of work, but it's really not going to be. Okay. All right, so I'm going to go ahead and say limit as x approaches 0. Alright, let's do the numerators. Okay, when we multiply a square root times another square root, and the radicand, what's inside, is exactly the same, all we do is lift the radical sign. So a square root of 4 plus x times another square root of 4 plus x, that's just a 4 plus x without the radical anymore. Okay? Alright, so next we're going to multiply this square root times that 2 in the back. Okay, and you probably see what's going to happen, but I'll go ahead and multiply. I'm just going to put that 2 in front. Okay, that's square root of 4 plus x. So this 2 back here times this square root right there. Okay, alright, what's next? Well, for the inside, now I have a negative 2. Okay, this time it's a negative 2 times that square root, so I have a negative 2. And if you saw it earlier that those will cancel out, you don't have to spend time writing that. Okay, and the last thing we'll do for the numerator is this negative 2. Let's do this in brown. This negative 2 times that positive 2, we get a negative 4. Okay, now another key thing is don't try to multiply when you do start. Okay, all right, I can simplify that, but what we're going to do in the denominator, okay, the key part is, okay, don't actually multiply this x times that radical and that x times that 2. Just leave them as being multiplied factors. So I'm going to write an x. I'll put this right here in parentheses. Okay, I don't want to bother multiplying that. Okay, so next step. A lot of writing, but there really is not that many steps. Alright, let's simplify the numerator. Okay, Alright, and we see right off that these two terms in the middle will cancel out, and that's why we multiply by the conjugate. So in the numerator, I just have a 4x and a minus 4. Okay? In the denominator, I have this right here. Okay, what will we do next? Okay, looking back at it, I see I didn't do the numerator right. That's why I didn't know how to do my next step. Okay, I didn't simplify my numerator correctly. That's a 4 plus x and a minus 4. Okay, the 4, this 4, and this negative 4 cancel. So all I really have in the numerator is just an x. Okay, all that long stuff in the numerator just becomes an x. Now I'm going to write my denominator again. Okay, I see now that these x's will cancel. Okay, now I'm going to put a little 1 up here because I need something in my numerator. So I'm going to rewrite this one more time. X approaches 0. So my top is just a 1. These two x's will go away. And again, I don't need the parentheses. I'm about to write a parenthesis there. I have a square root of 4 plus x, then a plus 2. Alright, let's substitute 0 in this time. Okay, I'm going to substitute that 0 right there. You get 1 over square root of 4 plus 0 plus 2. Okay, the 4 plus 0 is the square root of 4. Okay, square root of 4 is a 2. So my final answer, my limit is 1/4. Okay, so that hard-looking problem, a lot of writing, but not really that many steps. Okay, let's try another one. Okay, this one's done slightly different. Okay, but let's check first. Check for plug again. This 3 right there, 3 plus 22, we get a square root of 25 minus 5. We'll see the denominator is 0, right? Okay, let's plug in the 3 in the numerator. 3 minus 3, that's a 0. We get a 0 over 0. So we have to do some kind of manipulation here. Okay, now sometimes on the last problem the square root was in the numerator. This time I put the square root term in the denominator. So we're going to multiply by the square root of this right here. We're going to do this to the bottom. It's going to work out the same. Okay? Alright. So let's do the numerator. Okay? So again, leave this right here, just like the last problem. Don't try to multiply that x minus 3 times that square root. It can be done, of course, but you'll find out that you just want to leave it like that. Alright, let's do the denominator. Okay, let's just highlight things. This times this, okay, that'll be x plus 22. Okay, alright, let's do this. This times the plus 5, okay, and again, you wouldn't have to write it out because you're going to realize that those are going to cancel out, okay, but I'll write it out. Okay, let's keep going. Let's see, we're going to multiply this negative 5 times that right there. And erase that so you can see it. Okay, so we have, like you'd think, a negative 5. So you see those two terms are going to cancel out. And finally, we're going to multiply this negative 5 times that positive 5, we get a negative 25. Alright, let's see if I can combine. Now let's combine, leave the top alone this time. Let's combine the bottom. Okay, first things first, very obvious. These two cancel out. Thank goodness. We don't want to write all that again. Okay. Up. All right. Let's see this. Let's see. X plus 22. All right. We got this right here. We got a plus 22. I got a minus 25. That become an x minus 3. And we have that x. So this time the x's do not cancel out. Okay. We have an x minus 3 in the denominator. All that long stuff just becomes x minus 3. Okay, well, good for us because when I looked at the numerator, we had that. Okay, all right, we see that the x minus 3's will cancel. Okay, so we're going to have the limit as x approaches 3 of this right here. X plus 22 plus 5. We're going to substitute our 3. We're going to have the square root of 3 plus 22 plus 5. We get the square root of 25 plus 5. We get a 5 plus 5. Our answer is 10. So that's how you do those kind of problems. Again, use what I call a conjugate, and the part that's the side of the fraction that's not the conjugate, don't multiply them out, because later on you have a term there, they'll cancel out. Okay, that's how you do it.